Good morning. My name is V. Selvam, Assistant Professor, Mechanical Engineering in Kongunadu College of Engineering and Technologies. I take about the subject of Dynamics of Machines, the Unit 5, Mechanism for Control. Mechanism for control, there are two types of there. One is the governor, another one is the gyroscope. Now I take about the subject of governor. The topic is the governors. The function of governor is to automatically maintain the speed of the engine within specified limit whenever there is a variation of load. If the load on the engine is increases, its speed decreases, so it becomes necessary to increase the fuel supply by opening the throttle valve. On the other hand, when the load on the engine is decreases, its the speed increases and the fuel supply is to be decreases by the closing the throttle valve. Thus, governor keeps the speed of the engine within certain limits by regulating the fuel supply as per load requirements. The petrol, for example, the petrol engine governor manifolds the throttle valve, and the diesel engines it manifolds the fuel pump. The differentiate with the governor and the flywheel. The governor is regulate the mean speed of engine whenever there are load variations, whereas the flywheel reduce the fluctuation of speed caused by the fluctuation of engine turning moment during each cycle of operations. The type of governors. What are the types of governors? The first centrifugal governors and inertial governors. Centrifugal governors can be divided into the two types. One is the watt governor or pendulum type. Second one is the loaded type governors. Loaded type governors can be divided into two types. One is the dead weight governors, another one is the spring controlled governors. Dead weight governors is portal governor and flywheel governors. Spring loaded governors, first one Hartnell governor, Harting governor, Wilson Hartnell governor and Pickering governors. The second type of governor is inertia governors. Inertia governor, this governor is more sensitive than the centrifugal, but it become very difficult to completely balance the revolving parts. Now the centrifugal governors. This is the figure in centrifugal governors. This is the most common type of governor. The centrifugal type of governors rotating of the crankshaft is taken into a vertical spindle through the suitable gears. It consists of two balls of equal masses which are attached to the arms. These balls are known as the governor balls or fly balls. Their upper arms are keyed to the spindle. The sleeve surround the spindle as shown and can rotate as well as slide over the spindle. One end of the bell crank lever is attached to the sleeve and other to the rod which actuated the fuel supply valves. The centrifugal governors are based on the balancing of centrifugal force on the rotating balls by an equal and opposite radial force. When the load of the engine is decreases, the engine and the governor speed is increases. This increases the centrifugal force acting on the balls and the balls moves radially outwards. Therefore, the sleeve rise upwards. This upward movement of sleeve reduces the supply of the working fluid and hence the speed is decreased. Thus, the engine speed falls and comes near about the mean speed. Similarly, when the load is increases, the speed of the engine and the governor decreases. This results in the decrease of centrifugal force on the balls, and the balls moves inward and the sleeve moves downwards. The downward movement of sleeve increases the supply of the working fluid and hence the speed is increases. Thus, the engine speed rises and comes near about the mean speed. Then centrifugal force. Centrifugal force exerted by the fly balls radially outward is known as the centrifugal force of governor. It is given by Fc is equal to m into omega squared into r, where m is the mass of the fly balls, omega is the angular speed of the governor, r is equal to radius of the rotations. The controlling forces, an equal and opposite force to the centrifugal force acting radially inward in terms as controlling force of governor. In other words, the force acting radially upon the rotating balls to counteract its centrifugal force is called the controlling force. Then the centrifugal governors can be divided into two types. One is the watt governor, another is the loaded type of governors. First, watt governor. This is the diagram for watt governors. The simplest form of centrifugal governor is a watt governor shown in figure. It is basically a conical pendulum with the links attached to the sleeve of negligible mass. The arm of the governor may be connected to the spindle in the following three ways. The pivot P may be on spindle axis shown in figure, that is the A. Then second one, the pivot B may be offset from the spindle axis and the arms when produced intersect at O is the shown in figure B. The pivot B may be offset but the arms cross the axis at O in the shown in figure C, where m is the mass of the ball in kg, w weight of the ball in newtons, t tension in the arm in newtons, omega angular velocity of arm and the ball about the spindle axis in radians per second. R equal to radius the path of rotation of the ball, that is the horizontal distance from the center of the ball to the spindle axis in meters. Fc centrifugal force acting on the ball in newtons. Then h is equal to height of the governor in meters. It is assumed that the weight of the arms, links and sleeve are negligible as compared to the weight of the balls. Now ball is in equilibrium under the action of the centrifugal force Fc acting on ball, the tension T in the arm, the weight W of the balls. Taking moment about the point, we have Fc into h is equal to W into R. W is equal to m into g into r. Then Fc m into omega squared into r into h is equal to m into g into r. When the g is expressed in the meter per second squared and omega in radians per second, and the height h is the meter, n is the speed in rpm, then omega is equal to 2 pi n divided by 60. The h is equal to 9.81 divided by 2 by n 60 whole squared. Then second type of loaded type governors. Loaded type governors, the portal governor, another one is the proel governor. Portal governor, the portal governor is modification of watt governors with the center load attached to the sleeve is shown in figure. This is the modification led to large centrifugal forces, that is the higher speeds are needed to bring the fly ball to the same radiuses. Let m is equal to mass of the each ball in kg, capital M is equal to mass of the center load in kg, W is equal to m into g, weight of each ball in newton, then W is equal to m into g, weight of the center load in newton, R is equal to radius of rotation in meter, h is equal to height of the governor in meter, n is equal to speed of the ball in rpm, omega is equal to 2 by n divided by 60, that is the angular speed of the ball in radians per second. X is equal to m into omega squared into r, that is the centrifugal force acting on the ball in newtons. Alpha means angle of inclination of the upper link to the vertical, beta angle of inclination of the lower link to the verticals. The analysis of portal governors. The instantaneous center of I, the instantaneous center of I lies at the point of intersection of the line AB and perpendicular to the spindle axis through C. PD is perpendicular to IC shown in figure. Taking moment about the point I, Fc into Bd is equal to mg into Id plus m into g divided by 2 into Ic. Fc means that is the m into g, Id divided by Bd plus capital M into g divided by 2 into Ic divided by Bd. Then Ic is equal to split in the Id plus Dc in the figure. In the figure B, that is split in the Id, that is Ic is equal to Id plus Dc. Then m into g into Id divided by Bd plus capital M into g divided by 2 into Ic plus Dc divided by Bd. So m into g tan alpha plus m dot g divided by 2 into tan alpha plus tan beta. Tan alpha plus tan beta is equal to 1. Is substitute the equation dividing both sides tan alpha. The Fc divided by tan alpha is equal to m into g plus capital M into g divided by 2 into 1 plus tan beta divided by tan beta is equal to m into g plus capital M into g divided by 2 1 plus q. Tan beta divided by tan alpha is equal to q. Then Fc is equal to m into omega squared r and tan alpha is equal to r by h. Substitute the equations. You find out the height. Then h is equal to m plus capital M divided by 2 into 1 plus q divided by m into g by omega squared. Tan alpha divided by tan beta is equal to 1 means q is equal to 1. Then q is equal to 1 means h is equal to small m plus capital M divided by m into g divided by omega squared. Thank you.